Near-field communication. Near-field communication NFC is a set of communication protocols for communication between two electronic devices over a distance of 4 cm, 11/2 in or less. NFC offers a low-speed connection with simple setup that can be used to bootstrap more capable wireless connections. NFC devices can act as electronic identity documents and keycards. They are used in contactless payment systems and allow mobile payment replacing or supplementing systems such as credit cards and electronic ticket smart cards. This is sometimes called NFC/CTLS or CTLS NFC, with contactless abbreviated CTLS. NFC can be used for sharing small files such as contacts and bootstrapping fast connections to share larger media such as photos, videos, and other files. Overview. Near-field communication NFC describes a technology which can be used for contactless exchange of data over short distances. Two NFC-capable devices are connected via point-to-point contact over a distance of 0 to 2 cm. This connection can be used to exchange data such as process data and maintenance and service information between the devices. This interface can be used for parameterization of the component as well. NFC-enabled portable devices can be provided with application software, for example to read electronic tags or make payments when connected to an NFC-compliant system. These are standardized to NFC protocols, replacing proprietary technologies used by earlier systems. Like other proximity card technologies, NFC is based on inductive coupling between two so-called antennas present on NFC-enabled devices, for example a smartphone and a printer communicating in one or both directions, using a frequency of 13.56 MHz in the globally available unlicensed radio frequency ISM band use. Every active NFC device can work in one or more of three modes. NFC card emulation enables NFC-enabled devices such as smartphones to act like smart cards, allowing users to perform transactions such as payment or ticketing. See host card emulation. NFC reader/writer enables NFC-enabled devices to read information stored on inexpensive NFC tags embedded in labels or smart posters. Nfc Peer-to-Peer enables two NFC-enabled devices to communicate with each other to exchange information in an ad hoc fashion. NFC tags are passive data stores which can be read, and under some circumstances written to, by an NFC device. They typically contain data, as of 2015, between 96 and 8,192 bytes, and are read only in normal use, but may be rewritable. Applications include secure personal data storage, e.g. debit or credit card information, loyalty program data, personal identification numbers PIN, contacts. NFC tags can be custom encoded by their manufacturers or use the industry specifications. The standards were provided by the NFC Forum. The forum was responsible for promoting the technology and setting standards and certifies device compliance. Secure communications are available by applying encryption algorithms as is done for credit cards and, if they fit the criteria, for being considered a personal area network. The standards include ISO/IEC 18092 and those defined by the NFC Forum. In addition to the NFC Forum, the GSMA Group defined a platform for the deployment of GSMA NFC standards within mobile handsets. GSMA's efforts include Trusted Services Manager, Single Wire Protocol, Testing/Certification, and Secure Element. A patent licensing program for NFC is under deployment by France Brevets, a patent fund created in 2011. This program was under development by Via Licensing Corporation, an independent subsidiary of Dolby Laboratories, and was terminated in May 2012. A platform independent free and open source NFC library. Present and anticipated applications include contactless transactions, data exchange, and simplified setup of more complex communications such as Wi-Fi. In addition, When one of the connected devices has internet connectivity, the other can exchange data with online services. History. Design. NFC is a set of short-range wireless technologies, typically requiring a separation of 10 cm or less. NFC operates at 13.56 MHz on ISO/IEC 18000-, 3-air interface, and at rates ranging from 106 kbps to 424 kbps. NFC always involves an initiator and a target. The initiator actively generates an RF field that can power a passive target. This enables NFC targets to take very simple form factors such as unpowered tags, stickers, key fobs, or cards. NFC peer-to-peer communication is possible, provided both devices are powered. NFC tags contain data and are typically read-only, but may be writable. They can be custom encoded by their manufacturers or use NFC forum specifications. The tags can securely store personal data such as debit and credit card information, loyalty program data, PIN and networking contacts, among other information. The NFC forum defines 4 types of tags that provide different communication speeds and capabilities in terms of configurability, memory, security, data retention, and write endurance. Tags currently offer between 96 and 8,192 bytes of memory. As with proximity card technology, NFC uses inductive coupling between 2 nearby loop antennas, effectively forming an air-core transformer. Because the distances involved are tiny compared to the wavelength of electromagnetic radiation radio waves of that frequency, about 22 meters, the interaction is described as near field. Only an alternating magnetic field is involved, so that almost no power is actually radiated in the form of radio waves, which are electromagnetic waves, also involving an oscillating electric field that essentially prevents interference between such devices and any radio communications at the same frequency or with other NFC devices much beyond its. They operate within the globally available and unlicensed radio frequency ISM band of 13.56 MHz. Most of the RF energy is concentrated in the +7 kHz bandwidth allocated for that band, but the emission's spectral width can be as wide as 1.8 MHz in order to support high data rates. Working distance with compact standard antennas and realistic power levels could be up to about 20 cm, but practically speaking, working distances never exceed 10 cm. Note that because the pickup antenna may be quenched by nearby metallic surfaces, the tags may require a minimum separation from such surfaces. The ISO/IEC 18092 standard supports data rates of 106, 212, or 424 kbps/s. The communication takes place between an active initiator device and a target device, which may either be passive. The initiator device provides a carrier field, and the target device, acting as a transponder, communicates by modulating the incident field. In this mode, the target device may draw its operating power from the initiator-provided magnetic field. Active. Both initiator and target device communicate by alternately generating their own fields. A device stops transmitting in order to receive data from the other. This mode requires that both devices include power supplies. NFC employs 2 different codings to transfer data. If an active device transfers data at 106 kbps/s, a modified Miller coding with 100% modulation is used. In all other cases, Manchester coding is used with a modulation ratio of 10%. Standards. NFC standards cover communications protocols and data exchange formats, and are based on existing RFID standards including ISO/IEC 14000, 443, and FELI-CA. The standards include ISO/IEC 18092 and those defined by the NFC Forum. ISO/IC. NFC is standardized in ECM-AMINIS 340 and ISO/IEC 18092. These standards specify the modulation schemes, coding, transfer speeds, and frame format of the RF interface of NFC devices, as well as initialization schemes and conditions required for data collision control during initialization for both passive and active NFC modes. They also define the transport protocol, including protocol activation and data exchange methods. The air interface for NFC is standardized in ISO/IEC 18092/ECM, ABNIS 340 Near-Field Communication Interface, and Protocol-1 NFCIP-1, ISO/IEC 21481/ECM, ABNIS 352 Near-Field Communication Interface, and Protocol-2 NFCIP-2 NFC incorporates a variety of existing standards include 443 Type and Type B in Felicom. NFC-enabled phones work at a basic level with existing readers. In card emulation mode, an NFC device should transmit, at a minimum, a unique ID number to a reader. In addition, NFC Forum defined a common data format called NFC Data Exchange Format (NDEF) that can store and transport items ranging from any MIME-typed object. The NFC Forum added the simple NDEF exchange protocol SNP to the spec that allows sending and receiving messages between two NFC devices. GSMA. The GSM Association GSMA is a trade association representing nearly 800 mobile telephony operators and more than 200 product and service companies across 219 countries. Many of its members have led NFC trials and are preparing services for commercial launch. GSM is involved with several initiatives. Standards GSMA is developing certification and testing standards to ensure global interoperability of NFC services. Pay by Mobile Initiative seeks to define a common global approach to using NFC technology to link mobile devices with payment and contactless systems. On November 17, 2010, after 2 years of discussions, AT&T, Verizon, and T-Mobile launched a joint venture to develop a platform through which point-of-sale payments could be made using NFC in cell phones. Initially known as AT&T's mobile wallet and later as SoftCard, the venture was designed to usher in broad deployment of NFC technology, allowing their customers' NFC-enabled cell phones to function similarly to credit cards throughout the U.S. Following an agreement with and IP purchase by Google, the SoftCard payment system was shuttered in March 2015 with an endorsement for its earlier rival, Google Wallet. Stow Alpine Store Logistics and Payment with NFC is a pan-European consortium supported by the European Commission's Information Society Technologies Program. Stow Alpine will examine the potential for NFC local wireless mobile communication. NFC Forum is a non-profit industry association formed on March 18, 2004 by NXP Semiconductors, Sony, and Nokia to advance the use of NFC wireless interaction in consumer electronics, mobile devices, and PC. Standards include the 4 distinct tag types that provide different communication speeds and capabilities covering flexibility, memory, security, data retention, and write endurance. NFC Forum promotes implementation and standardization of NFC technology to ensure interoperability between devices and services. As of January 2020, the NFC Forum had over 120 member companies. NFC Forum promotes NFC and certifies device compliance and whether it fits in a personal area network. Other standardization bodies. GSMA defined a platform for the deployment of GSMA NFC standards within mobile handsets. GSMA's efforts include single wire protocol, testing and certification, and secure element. The GSMA standards surrounding the deployment of NFC protocols governed by NFC Forum on mobile handsets are neither exclusive nor universally accepted. For example, Google's deployment of host card emulation on Android KitKat provides for software control of a universal radio. In this HC deployment, the NFC protocol is leveraged without the GSMA standards. Other standardization bodies involved in NFC include Etsy/SCP Smart Card Platform to specify the interface between the SIM card and the NFC chipset. MCO for the impacts on the EMV payment applications. NFC allows one- and two-way communication between endpoints, suitable for many applications. Commerce. NFC devices can be used in contactless payment systems, similar to those used in credit cards and electronic ticket smart cards, and allow mobile payment to replace/supplement these systems. In Android 4.4, Google introduced platform support for secure NFC-based transactions through host card emulation HCE for payments, loyalty programs, card access, transit passes, and other custom services. HCE allows any Android 4.4 app to emulate an NFC smart card, letting users initiate transactions with their device. Apps can use a new reader mode to act as readers for HCE cards and other NFC-based transactions. On September 9, 2014, Apple announced support for NFC-powered transactions as part of Apple Pay. With the introduction of iOS 11, Apple devices allow third-party developers to read data from NFC tags. Bootstrapping other connections. NFC offers a low-speed connection with simple setup that can be used to bootstrap more capable wireless connections. For example, Android Beam software uses NFC to enable pairing and establish a Bluetooth connection when doing a file transfer, and then disabling Bluetooth on both devices upon completion. Nokia, Samsung, BlackBerry, and Sony have used NFC technology to pair Bluetooth headsets, media players, and speakers with one tap. The same principle can be applied to the configuration of Wi-Fi networks. Samsung Galaxy devices have a feature named S-Beam, an extension of Android Beam, that uses NFC to share a MAC address and IP addresses and then uses Wi-Fi Direct to share files and documents. The advantage of using Wi-Fi Direct over Bluetooth is that it permits much faster data transfers, running up to 300 Mbit/s. Social networking. NFC can be used for social networking, for sharing contacts, text messages and forums, links to photos, videos, or files, and entering multiplayer mobile games. Identity and access tokens. NFC-enabled devices can act as electronic identity documents found in passports and ID cards, and keycards for the use in fare cards, transit passes, login cards, car key and access badges. NFC short range and encryption support make it more suitable than less private RFID systems. Smartphone automation and NFC tags. NFC-equipped smartphones can be paired with NFC tags or stickers that can be programmed by NFC apps. These programs can allow a change of phone settings, texting, app launching, or command execution. Such apps do not rely on a company or manufacturer but can be utilized immediately with an NFC-equipped smartphone and an NFC tag. The NFC Forum published the signature record type definition RTD 2.0 in 2015 to add integrity and authenticity for NFC tags. This specification allows an NFC device to verify tag data and identify the tag author. Gaming, gaming, gaming. NFC has been used in video games starting with Skylanders, Spyro's Adventure. These are customizable figurines which contain personal data with each figure. Nintendo's Wii U was the first system to include NFC technology out of the box via the gamepad. It was later included in the Nintendo 3DS range being built into the new Nintendo 3DS/XL and in a separately sold reader which uses infrared to communicate to older 3DS family console. The Amiibo range of accessories utilize NFC technology to unlock features. Sports. Adidas Telstar 18 is a soccer ball that contains an NFC chip within. The chip enables users to interact with the ball using a smartphone. Bluetooth comparison. NFC and Bluetooth are both relatively short-range communication technologies available on mobile phones. NFC operates at slower speeds than Bluetooth and has a much shorter range, but consumes far less power and doesn't require pairing. NFC sets up more quickly than standard Bluetooth, but has a lower transfer rate than Bluetooth Low Energy. With NFC, instead of performing manual configurations to identify devices, the connection between two NFC devices is automatically established in less than 1 second. The maximum data transfer rate of NFC 424 kbit/s is slower than that of Bluetooth v2.12.1 mbit/s. NFC maximum working distance of less than 20 cm reduces the likelihood of unwanted interception, making it particularly suitable for crowded areas that complicate correlating a signal with its transmitting physical device and, by extension, its user. NFC is compatible with existing passive RFID 13.56 MHz ISO/IEC 18000-3 infrastructures. It requires comparatively low power, similar to the Bluetooth v4.0 low energy protocol. When NFC works with an unpowered device, e.g., on a phone that may be turned off, a contactless smart credit card, a smart poster, however, the NFC power consumption is greater than that of Bluetooth v4.0 low energy, since illuminating the passive tag needs extra power. Devices. In 2011, handset vendors released more than 40 NFC-enabled handsets with the Android mobile operating system. BlackBerry devices support NFC using BlackBerry Tag on devices running BlackBerry OS 7.0 and greater. MasterCard added further NFC support for PayPass for the Android and BlackBerry platforms, enabling PayPass users to make payments using their Android or BlackBerry smartphones. A partnership between Samsung and Visa added a PayWave application on the Galaxy S4 smartphone. In 2012, Microsoft added native NFC functionality in their mobile OS with Windows Phone 8, as well as the Windows 8 operating system. Microsoft provides the Wallet Hub in Windows Phone 8 for NFC payment and can integrate multiple NFC payment services within a single application. In 2014, iPhone 6 was released from Apple to support NFC. And since September 2019 in iOS 13, Apple now allows NFC tags to be read out as well as labeled using an NFC app. Deployments. As of April 2011, hundreds of NFC trials had been conducted. Some firms moved to full-scale service deployments, spanning one or more countries. Multi-country deployments include Orange's rollout of NFC technology to banks, retailers, transport, and service providers in multiple European countries, and Airtel Africa and Oberthur Technologies deploying to 15 countries throughout Africa. China Telecom, China's third-largest mobile operator, made its NFC rollout in November 2013. The company signed up multiple banks to make their payment apps available on its SIM cards. China Telecom stated that the wallet would support coupons, membership cards, fuel cards, and boarding passes. The company planned to achieve targets of rolling out 40 NFC phone models and 30 NFC SIM by 2014. Softcard, formerly ICI's mobile wallet, a joint venture from Verizon Wireless, AT&T Mobile, focuses on in-store payments making use of NFC technology. After doing pilots in some regions, they launched across the U.S. Vodafone launched the NFC-based Vodafone Smart Pass mobile payment service in Spain in partnership with Visa. It enables consumers with an NFC-enabled SIM card in a mobile device to make contactless payments via their Smart Pass credit balance at any POS. OT, an Israeli company that designs and develops contactless microprocessor-based smart card technology, contracted to supply NFC readers to one of its channel partners in the U.S. The partner was required to buy $10 worth of OTI NFC readers over 3 years. Rogers Communications launched virtual wallet SureTap to enable users to make payments with their phone in Canada in April 2014. SureTap users can load up gift cards and prepaid MasterCards from national retailers. Sri Lanka's first workforce smart card uses NFC. As of December 13, 2013, Tim Hortons Timmy BlackBerry 10 application allowed users to link their prepaid TIM card to the app, allowing payment by tapping the NFC-enabled device to a standard contactless terminal. Google Wallet allows consumers to store credit card and store loyalty card information in a virtual wallet, and then use an NFC-enabled device at terminals that also accept MasterCard PayPass transactions. Germany, Austria, Finland, New Zealand, Italy, Iran, Turkey, and Greece trialed NFC ticketing systems for public transport. The Lithuanian capital of Vilnius fully replaced paper tickets for public transportation with ISO/IEC 14443 type cards on July 1, 2013. NFC sticker-based payments in Australia's Bank Miku and card issuer Cuscal completed an NFC payment sticker trial, enabling consumers to make contactless payments at Visa Pay Wave terminals using a smart sticker stuck to their phone. India was implementing NFC-based transactions in box offices for ticketing purposes. A partnership of Google and Equity Bank in Kenya introduced NFC payment systems for public transport in the capital city Nairobi under the branding Baba Pay. January 2019 saw the start of trial using NFC-enabled Android mobile phones to pay public transport fares in Victoria, Australia. Criticism. Vulnerabilities. Although the range of NFC is limited to a few centimeters, standard plain NFC is not protected against eavesdropping and can be vulnerable to data modifications. Applications may use higher-layer cryptographic protocols to establish a secure channel. The RF signal for the wireless data transfer can be picked up with antennas. The distance from which an attacker is able to eavesdrop the RF signal depends on multiple parameters, but is typically less than 10 meters. Also, eavesdropping is highly affected by the communication mode. A passive device that doesn't generate its own RF field is much harder to eavesdrop on than an active device. An attacker can typically eavesdrop within 10 m of an active device and 1 m for passive devices. Because NFC devices usually include ISO/IEC 14443 protocols, relay attacks are feasible. For this attack, the adversary forwards the request of the reader to the victim and relays its answer to the reader in real time, pretending to be the owner of the victim's smart card. This is similar to a man-in-the-middle attack. One lymph code example demonstrates a relay attack using two stock commercial NFC devices. This attack can be implemented using only two NFC-enabled mobile phones. As NFC uses radio waves for data transfer, the possibility for any number of security attack vectors exists, such as eavesdropping, data corruption, data modification, and imposter attacks man-in-the-middle. Limitations. NFC and its base technology, that the standard is built from RFID, has been criticized for its lack of long-range support up to a maximum 20 cm distance. Future considerations. Ultra-wideband UWB, another radio technology, has been hailed as a future possible alternatives to NFC technology due to further distances of data transmission, as well as Bluetooth and wireless technology.